Hi everyone, and welcome to today's webinar, How LogicMonitor Evolved Their Monitoring and How You Can Too, sponsored by LogicMonitor. I'm Jenna Sargent, news editor of SD Times and IT Ops Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website about 24 hours after the event. Second, if at any time you have questions about or during the presentation, you can submit them using the chat. Now moving on to today's webinar topic. Digital transformation for some people is just another buzzword repeated by their organization wanting to migrate to the cloud without any concrete plan of implementation. We're not going to lie to you, digital transformation isn't simple and it isn't easy, but with a foolproof implementation plan, you can start to feel the tangible effects of better agility, resiliency, and efficiency that come with modernizing your business into the cloud. LogicMonitor's experienced site reliability engineers will share with you tips and tricks learned during their evolution and how to apply that into a foolproof strategy so you too can modernize your monitoring into the cloud. Our speakers today include Colette Tomaszuk, Senior Manager of Product Marketing at LogicMonitor, and David Rickel, Site Reliability Engineer at LogicMonitor. Now to get things started, I will turn it over to you, Colette.
Hey everyone, good morning. So what we'll cover today is three things. We're going to talk about why digital transformation and modernization actually matters to ops teams, and that includes all ops teams. And then we'll talk about benefits of being a champion for digital transformation within your ops teams, and David will share his experiences with that. And lastly, we'll kind of talk you through our own digital transformation, what we learned, and other tips that you can leverage when migrating to the cloud. But before we dive in, wanted to share a little more info about us at LogicMonitor, who we are, and what it is that we actually do. So as a unified observability platform, LogicMonitor offers a comprehensive visibility across infrastructure, networks, cloud, containers, and applications, leveraging robust context with detailed correlation and intelligence, giving you the insights you need to enable automation and problem resolution across all ops teams. So now for the fun stuff. So digital transformation, it's not one size fits all. And it's not just another overused buzzword either. It's more of a constant state of mind around being in a continuous cycle that really forces enterprises to adopt new cloud technology at rapid speed. And often it's faster than they can keep up with around migrating or even re-architecting their infrastructure and applications onto that cloud environment. But the thing is, most don't realize, or they often forget, that with any type of transformation, it isn't one size fits all, and it truly is okay to cloud at your own pace. So at LogicMonitor, not only do we support enterprises at any and every stage of their digital transformation and cloud journey, but in order to maintain and accelerate innovation around the quality of product and services we deliver, we work with our own internal teams using LogicMonitor every single day to improve, optimize, and innovate. And a big part of that is our tech ops team, who is responsible for cloud operations and site reliability engineering. So today you're going to hear all the scoop from David, our site reliability engineer at LogicMonitor, on his journey through our own transformations for growth and scale, and as we continue to navigate new challenges and innovate ways around our own operations and the experiences of customers. So here's David.
Hey guys, my name's David Rickel. I am a site reliability engineer here at LogicMonitor, and I've been with the company for about 4 years. Started off in the infrastructure space, dealing primarily with the physical hardware as we were still primarily on-prem, and moving on to more cloud-based activities, and now keeping the entire site up on a daily basis. So when I first started at LogicMonitor 4 years ago, we were dealing primarily with 3 different co-locations. They're going to be in London, in Los Angeles, and in Virginia. These were just distributed locations. We were originally based out of Santa Barbara in California and in Austin, Texas, so completely remote sites. So we had to use smart hands. And I'm not sure if you guys are familiar with smart hands or have used them in the past. These are remote technicians that will go and unplug cables, unrack devices, change drives out, pretty basic normal troubleshooting and stuff you do in a data center. Well, when I first joined LogicMonitor, I was pretty new to the whole monitoring space in general, and so being able to get kind of my onboarding along with how LogicMonitor is used was really key to kind of getting my head in the same space that the engineers I was working with were at, as well as being able to quickly see how useful LogicMonitor was as a tool. So one of my first interactions was having to deal with replacing a couple of SSDs on a Dell server in one of our racks in our Los Angeles data center. It's not that big of a cage. It's like 4 racks, nothing major. So we call the engineer, give him all the information. He gets to the site. We're like, hey, so it's going to be this rack, this RU, this is the serial number. Verify all these things before you touch anything. Let us know what you're doing before you're doing it. Go ahead and, we need you to go ahead and power the device off so we can get this going. So it should be the one that's blinking. So I wait a few seconds. One of the other engineers sitting next to me inside of our office goes, hey, we got a device down and over here we're not supposed to have this down. So I stop and I'm on the phone with the engineer, say, hey, whatever you unplugged, plug it back in. I'm not sure what you did, but that's the wrong area. You're 2 racks over, not in the right spot. Engineer's like, okay, no problem, I got it. And so it gets plugged back in. We see the alert leave. There's no longer stuff going off. And we're like, okay, well, just verify the RU, verify the rack. Here's the serial number. Go, handle this thing. A few seconds later, engineer pipes up again. Hey, the other rack's going off now. Also not the one you're working in. I stop and tell the guy, I'm like, hey, whatever you unplugged, just plug it back in, please. Turns out, as the guy was walking around, he was forgetting not only the RU, but the rack he was in, and just unplugging power cords. So it was that kind of like immediate sort of I don't want to say kind of a trial by fire that let me know perhaps the cloud might be a little bit better option for some of us, and definitely for LogicMonitor, which is why me and the other engineers all kind of agreed that it was time to make our transition out of the data center space. So one of the big reasons why we looked at this and we really wanted to move into the cloud is that a lot of our customers use cloud-based monitoring. And we're one of the largest customers as the technical operations team inside of LogicMonitor that uses the product across all of our different regions and spaces. So we are constantly drinking our own champagne. Some people like to say eating your own dog food. I don't like eating dog food, so I prefer the champagne aspect. But it's this constant feedback loop of us looking at things just as customers would look at things and then relaying these back to our product and development teams to constantly improve the product. Like half of the feedback tickets they get come from the tech ops team. So one of the big things we decided as we were moving towards getting things into the cloud space, as opposed to just being in the data center, we really started looking more into tools like Terraform. We needed to be able to manage all of our infrastructure with code so that we could scale it and grow it, or do any sort of changes we need quickly and efficiently, and also consistently. This was a big problem with some of the data center aspects. Is sometimes you get servers that are installed that are legacy that haven't been decommissioned yet, but you still need them for critical applications. And so you're using this mix and this mismatched device thing where new servers and services would come up on different devices. It could be very confusing for people who weren't familiar with what was installed where. And as the team grew, it just became an unwieldy mess to have this variety in the data center, whereas we really needed that stability and that consistency. And tools like Terraform really helped us get that going in place. So one of the big things we also realize is, so if we're going to move into the cloud, we need to be able to not only monitor all of what is in the infrastructure that all the customers and all their portals are running on, but we also need to be able to monitor ourselves, because if we have no visibility into what we're using, and since we're using the product to monitor the product, we had to kind of set up a portal to monitor our portal so we could monitor while we monitor. It was an idea to basically maintain uptime as much as possible. And if anything happened to our portal, we were aware, whether we were, off, time hours, or we were sleeping, 3 o'clock in the morning, we would be alerted if our portal experienced any problems before even customers would notice anything. We set our threshold super low, so it was really quick to respond. And it helped us maintain really good uptime for, the entire time I've been here. So one of the things that we really wanted, and this was, as you heard from my little story, data center stuff sometimes has problems, and it can be anything from hardware failures to, a technician unplugging the wrong cable. And so we really needed to have more fault tolerance and the ability to scale a little bit faster. One of the things that, and I don't know if, anyone else has run into this, but Colo space is at a premium in a lot of places. It's very difficult to get racks that are right next to each other. It's difficult to get cages that are the right size you want. You can order things and it takes 6 months to fulfill them. You can't really grow your space very fast. And depending on how quickly you're growing, and LogicMonitor grew very quickly, almost 4 times the size since I've been here. We needed to be able to scale on the fly quickly and have fault tolerance across all of our new infrastructure that we're spinning up. So we are an Amazon shop. Despite all their antics last December of trying to make us look at GCP as a possible alternative, we use them, we like them, they're great. One of the big things that we liked about it, though, is the fact that instead of taking months to scale up, having to purchase devices, have them shipped to each location, technicians to install them, technicians to go back and fix cabling they may have made mistakes with, we basically decided that with AWS, we can just stamp this infrastructure out. It takes 30 seconds to spin up an instance. Suddenly, what took months now takes minutes. And that was incredibly useful for us to be able to scale outwards and puts us in a place to continue scaling even today. So with this and using Terraform to manage all our code, having almost everything in AWS, so we're managing that, building up the instances in AWS, we also needed to be able to use tooling that could help us with our CI/CD pipeline and to constantly make sure that if we are making changes or developers are giving us code we need to implement, we can roll this back quickly. So what we use Atlassian's Bitbucket and Bamboo for our code stash and our deployment engine. With the amount of devices we have and just being able to scale as quickly as we can, it makes it really important to be able to reflect this in our deployments, to be able to move them as quickly as possible, get them going to everything, and also be able to have that be consistent across every single area we deploy to. And for that, we decided we're going to use cellular-based architecture for all of our infrastructure. So what we did is, instead of having like a single monolithic service, which originally that's where LogicMonitor started. Everything was all on a single device in a single rack, somewhere in Los Angeles. And then as we grew, we broke off more microservices and we broke off more services and put them in different devices. And eventually we ended up with this modular cell-based design. And this gave us, extreme flexibility. We can put customers of any size in this infrastructure, and it's going to continue to run. And if for some reason there's a power outage or a rack gets kicked over, hopefully that never happens, we would have a little bit of redundancy, and we can spread these devices out because there was internal redundancy, and things would fail over really quickly. So it lets basically be a little bit more redundant, a little bit more resilient. And having this modular-based infrastructure let us also take this single building block that looks a very specific way and put it in many different locations. And so we could take this, and an example, we have 3 physical data centers, and we're in 4 different AWS regions. So we're in Los Angeles, Virginia, and London, and then we're also in US East 1, US West 2, EU West 1, and AP Southeast 2, with the capability to add more and grow more, because it's a lot easier to spin up a new region than it is to spin up a new data center. Quite expensive, lots of travel, lots of problems. So being able to scale, that was really helpful. Being able to actually just stamp our infrastructure out in each one of these locations and have the services up and running, and the consistency of the services really made the cloud offerings extremely nice. We could use so many different things to manage and run everything we're using in our infrastructure, and AWS provides these in all these regions. So it made it really simple. So for us, we are able to take, everything and break it up into smaller parts. So our cell-based architecture, what we're doing here is, by breaking things up into smaller pieces, it allows us to adjust things almost exactly on the fly or in reaction to customer changes. So if a customer suddenly grew rapidly, they added a lot of devices, they started monitoring a lot more stuff, their needs for capacity and compute and memory would all rise appropriately. So with that, we're able to, with the cellular-based approach, take the services and the things that we need to do the certain things they grew in, we could scale those reactively or with, in advance if we knew they were going to grow to a certain size. It really helped us basically handle customers as large as, 50,000 devices down to customers that have 5. It gives us a lot of flexibility in what we can monitor, and being able to change that on those incremental levels is really key. So being able to add these things incrementally really comes into effect with the fact we're using Kubernetes. Kubernetes is this amazing tool that has managed services in AWS, amazing. It's much more fun than having to deal with that in the data center. I can speak from experience on that. Having the managed stuff is really nice. But the thing is we can just say, hey, we're going to expand this. We want to scale this out. We want to make sure it maintains this amount of minimum and this amount of maximum, and it'll go in and out based upon horizontal auto scaling, but depending on our needs, which let us kind of almost set and forget a lot of the microservices that we use, because we can just give it a range, and based upon all of our testing and all of our data and just customer sizes, we know it's not going to exceed our maximum, and it's never going to go below the minimum. We know exactly what we're getting for, and so we can base costs and growth entirely upon those ranges without having to think too much about it, and they come back alive. So the other thing that we really like, especially about Kubernetes and our cellular-based infrastructure, is we have redundancy of both services and of the individual account backup infrastructure for every aspect. So the database is mirrored across several different devices, several different instances. The same with all of our ingress. All the different parts have backups within, and everything can scale a lot faster. In the data center, if you've got, for example, if you're using an array of some kind and you've got 2 spare drives and the third one dies, you're having problems. Well, with AWS, if one of the instances goes down, we can just pick another availability zone and scale right into that immediately, and we're back completely redundant again within minutes, as opposed to trying to ship things out. So what it does with this having, this kind of cellular isolation tactic, so we're not really beholden on a single failure killing everything. It really lets us also manage the memory and the compute power on a very individual basis. So we try to make things as consistent as possible from what we're capable of in every area by using this modular cellular-based infrastructure. What we can do on a per customer basis, though, is we can scale them up, can scale them down. If they have greater needs in a certain area, like an instance size needs to go up, we can do this really quickly, really easily. And it doesn't change anything else in the infrastructure. It just modifies that one piece that we needed to change. And being able to scale made that incredibly useful for us. So one of the big things that we liked about this is, since we can spin up test environments so quickly, we can just say, hey, create this block of cells that looks just like production, acts exactly like it, roll it up, put it here, have all the connections come up thanks to Terraform, already understanding how to set up the network devices and the ingresses. Having all of that work together very quickly allows a development team to request an environment for a specific change, and we can have it up and running for them within a day, completely tested and verified, and then back to them to start doing whatever sort of testing they need for deployment. And it made it a lot easier for us to handle multiple components that are being tested and modified at the same time, to quickly test these in isolated environments, and then we can put them in a more condensed environment, test them all working together. So it just really sped up the development speed. And that's where we come to the resiliency part. I've been talking about redundancy all the time. AWS has, besides last December, pretty good uptime across all their regions, all their areas. They're really solid. The same can't be said for basic data center equipment. If you have a bad firmware update that goes across several drives at a time, you don't find out until weeks later that Dell didn't know it was going to kill everything. You now have a massive problem. Whereas with EC2 instances, you can just say, oh no, one might have a problem in a week, spin up a new one, move data, replace. Very quickly, very easy to move. And by having these in this modular infrastructure, we can pop these in and out, we can upgrade, we can change things really quickly. And if something fails, we know beyond just using Kubernetes for a lot of our microservices, the instances themselves are really easy to spin up and replace things with. And that's a huge change from the data center, where if you don't have tons of backup hardware on hand, you're kind of beholden to what happens with firmware. If there's like some 0-day bug and an update that ruins many, many things, you're really kind of messed if you're in the data center only at times. You can do all you want to avoid it, but sometimes things happen. It's a little bit easier to kind of recover and not run into those problems by dealing with more cloud-based infrastructure. So been talking about Kubernetes a little bit here, K8s. We have a LogicMonitor tool we call Argus. So back in the day, a lot of our monitoring and a lot of monitoring in general was on a per device level. You would say, hey, I want this one rack server and this one rack to be monitored in these ways, and you would get updates and alerts and notifications for that. Well, once we started clustering these services and putting them together in Kubernetes, the ephemeral nature of these pods coming up and down, being replaced. They don't have the same identifiers. When EKS spins them up, they're totally different namespace ideas. They're in the same namespace, but they're not the same item. Argus lets us look at this and monitor from a service level instead of saying, hey, like a Kubernetes node or pod is down in this node area, in this namespace. We can say, oh, is the service still healthy? And that was a change for us moving to the cloud, moving to more using these containerized and cloud-based resources, is that being able to monitor the service itself when these ephemeral things are going up and down, depending on how it's scaling, if it's going up, if it's decreasing, depending on load, getting alerts based upon a single pod going offline was not really useful. Being able to see it from a service level was a game changer. And it kind of changed how we looked at monitoring for those. Originally, we were like, well, we just monitor all of them as they come up. And over time, and many on-call engineer tiers, we eventually got to the point where we needed to do something different instead of just setting everything to alerting off or setting it to a scheduled downtime. So with Argus, it allows us to look at these from a more service-based level, and it clears up our monitoring immensely by not having thousands of Kubernetes pods like up and being monitored. Instead, it's just all the individual services. So it changes the scope of what we're looking at, but it doesn't really reduce the granularity, because at the end of the day, it's going to be which pods are up, which pods are down, and that ephemeral nature, it's going to change so much that it's not useful information to know when one goes away or two go away. So being able to monitor at the service level was a game changer for us as we moved more into those, and will continue to be a game changer as we continue moving services into the cloud.
So I think that more or less covers, David, all of the insight scoop that we have slides for you to cover, but I have a few questions. Mm-hmm. So a lot of what we're hearing in the market as we're engaging with our own sales teams or with our customers or even analysts is a lot of times ops teams are still siloed in enterprises. So what are some challenges that you've experienced in working with other teams or aligning to get them all to the same initiative on how cloudy we should be? And then what are the risks or concerns that other teams might have had that impacted how your site reliability engineering team functions?
Yeah, so some of the big things we've run across, especially as we started transitioning more from the data center into the cloud, a lot of developers were still, at least at the time, more focused on those single monolithic applications, which when you're breaking things out of the cloud, you don't want everything on one EC2 instance. So you want it spread out in smaller ones because things get more expensive as they get bigger. So you want smaller ones to keep it a little bit more affordable and also more resilient, more redundant. Instead of having everything go offline if there's an availability zone going down, you really want that spread out. So a piece went down, the customer still has access to their portal. They can still get in and do all the things. A lot of developers, when I first started 4 years ago, when we were still primarily in the data center, were more focused on that kind of monolithic structure, breaking pieces off, but they still like that single thing. Since then, the big thing is once TechOps proved how useful the Kubernetes infrastructure could be and how resilient it is, the developers started changing, and now it's been just a cascade of ideas of what we can put in Kubernetes, what we can put in containers, how to get this as resilient as possible, as the tiniest possible things. Logging into some of these nodes for doing any sort of just checking for logs or anything, they're so small that there's almost no room to run anything, which is great because we can have tons of them for the same price as one larger node, which if that fails, you're looking at large failure. If a single pod goes offline, it's not that big of a deal. But that was one of the big, not really challenges, it was just a really mind shift that a lot of developers had to make in developing applications.
So I know we have a mix of roles with us on the webinar today, but for people just curious about other ops teams or how to unify and align to the same kind of business initiatives and outcomes, what would you say are the benefits of being a champion for cloud migration, digital transformation that might normally be beyond the scope of what people would imagine for a site reliability engineer?
I mean, probably the biggest reason and the champion thing that everyone likes is not getting paged for random memory DIMMs failing in the data center at 2 o'clock.
Oh, you mean you like your sleep at 2 a.m. in the morning and your weekends drinking coffee and taking walks?
Yeah. One of the big things, and this is one of the big initiatives we had, because when I first started, we didn't actually plan to go to the cloud. We were looking at expanding our data center footprint. We were going to keep services in the cloud just for the redundancy and the resiliency, but our core services were going to stay in data centers. And we were looking at expanding into the EU region more. We wanted to put up a data center near Sydney. We're looking at all these different locations where we wanted physical things, which sounded great for a vacation, but at the same time, it was more complex physical hardware that the reality is a lot of engineers coming up these days, especially younger engineers as they're coming out of college, they don't have that physical hardware experience. And you're looking at like basically a decreasing job role of the amount of people that can actually do a certain level of work and a certain tier of work. And it wasn't really scaling well. And then with cloud being so large and constantly growing, and just the ease at which people were already familiar, a lot of college courses already have people logging into like AWS or dealing with various other providers.
GCP stuff, yeah.
So it really made a lot of sense to go there, but also it was really reducing complexity for existing engineers was kind of one of our main ideas. Once you have like a certain type of server that could have different idiosyncrasies from another server, it could have a different build profile, there could be different hardware depending on what vendors you're using. There could be a lot of different permutations that an EC2 instance is a stamp. They all look like this in this region. So it made it a lot simpler to troubleshoot, a lot simpler to scale, just because everything looked identical no matter where it was. There wasn't, and this can sometimes happen. You'll notice that certain hardware vendors will prefer to use different types of memory vendors, different types of drive vendors, depending on where they're at geographically as well. So you'll notice that certain devices in London will have different configurations. The overall, like it's got 64 gigs of RAM and a 16-core CPU, that'll be the same, but the actual manufacturers may differ. So that was the thing, that being able to move to the cloud and have that kind of just completely ambiguated away, where it's simply, this is what it is. It's this EC2 instance that has these characteristics. That made it a lot easier for, one, the developers to write anything for. They didn't have to worry about weird constraints and timings and things. Instead, they could go, okay, well, I know what we have. And the same with the engineers. They know when they look at something in AWS that it's going to be the same as everything else.
No, everybody likes predictability. So I think that for the most part covers the majority of David's presentation. I think we have a few questions, so I think I'll pass it over to Jenna to see what those were.
Yeah, if anyone has any extra questions, feel free to put them in the chat and we'll get them answered for you. So what was the biggest hurdle in making the decision to go from primarily on-premises to primarily cloud?
For the engineers, it was just, well, we're already in the data center. We already know how this works. Why would we want to change things? And then the newer engineers are like, why are we in the data center? Why aren't we in the cloud? I think the biggest hurdle was finance. When you look at the basic hardware setup that goes inside of a data center, you're either leasing or you're purchasing. You might be renting. I don't know. Maybe you found it in your garage. Whatever. It's got some permanence to it that once it's paid off, you're done paying it off. You don't have to keep doing it. Where with AWS and these cloud providers, it's this constant service fees that come up every month. You scale out, you put more things in, it costs more money. The upfront cost is substantially lower because you're not paying $40 million for a rack of servers. You're paying a few $100,000 a month for the equivalent of all that, which you're like, hey, I'm saving money. But long term, after you would have paid off that $40 million, you're still going to be paying for some of those resources like in AWS. That was kind of the big thing. And then the chip shortage happened. And everyone decided, hey, probably a good idea not to rely on physical hardware because the prices started going up. It basically became a race to see which one was more expensive, and then just the delay in time that it takes to get any of these things shipped, delivered, even purchased in many cases. Really, once we overcame that financial kind of hill, it was like, okay, cool. All these other things we can stop worrying about because now it's very clear the only downside is, the time we're not wasting. So it ended up being a really positive move for there. But that was the biggest hurdle, was kind of the financial thing at first.
Were there, other than the finances, were there any other bottlenecks that you ran into when starting the transition?
Yeah. So one of the big things we ran into kind of early on was just the sheer amount of data we had residing in the data center. And if, cloud, when you're moving things around the world in various places, physical proximity does impact, how fast things transfer. So with some of these really huge customers that had a lot of data, we just couldn't get them into the cloud fast enough. And, the data, we had to move it in smaller chunks. It became this real kind of specific bottleneck for these. But then what happened was we basically made enough changes to our moving tools and how we can process this, and also how quickly our databases can be resolved. Also, just changes in how much we store on site as opposed to backing it up in an S3 bucket, which is just larger, cheaper, long-term storage in AWS. We basically just kept making progress that eventually put us to the point where we can move any size customer anywhere we want at this point.
Mm-hmm. Are there any technologies specifically that made the move to primarily cloud easier?
Terraform has been amazing. HashiCorp's Terraform has been incredible for all of our tool use cases. We use it every day. It's constantly letting us stamp out new infrastructure, whatever we need on the fly. It's literally changing a single variable inside one of our file structures and pressing apply, and it just goes through, puts it together, gets it up and running, makes all the connections, installs all the software. It's pretty amazing for being able to scale out. If there's anything that anyone's using besides that, I mean, take a look at Terraform. It's great.
Were there any downsides to the transition, or has it been overall an improvement?
I'd say it's overall an improvement. The real downside is I don't get to travel to Australia now to set up a data center for a few weeks. I would have liked sitting on the beach. That would have been exciting. Surf, maybe.
Can product marketing come? Your job sounds fun. Do you want to trade?
But no. Downsides, I can't really think of any major ones. Sure, in the long run, it's probably going to be slightly more expensive financially, but all the bonuses we're getting for that, like a little bit of extra cost, I think it's more than worth it. And I think long term, it's going to be a wash on expenses, and it's just going to be good growth for us and good growth for the team.
So thanks, David. Jen, I did just want to remind the audience that we have a few handouts available. If you click on the resources, additional webinar content, some case studies, more information on a platform demo, so additional resources for you guys to check out. And just wanted to thank everyone for hanging out with David and me.
Thanks, guys.
Thanks.
Thank you.